Hi folks, this is Professor Watts. I'm going to go through the practice problems on the final exam study guide for you. So the first one here says an economy had been operating at a full employment equilibrium with a real growth rate of 4%. A series of negative aggregate demand shocks hit this economy, causing spending growth to decline from 4% per year to negative 25% per year. Due to price and wage stickiness, the inflation rate can only decline by 12 percentage points. So we're going to use the aggregate demand supply diagram to show the initial equilibrium, the final equilibrium, and then to think about whether monetary policy responses would be proper in this situation. So I'm going to copy this over here into this drawing app I found. Here's my long run aggregate supply curve. It's a little tricky to do this on my drawing pad. Okay, here's an aggregate demand growth rate. Remember, we're thinking about everything in growth rates here. Because we think about real growth rate, that's down here, delta y, versus the inflation rate, that's represented by pi. And then long run aggregate supply, that's our potential, remember, based on using all the factors of production. So we're saying we're starting off at 4% growth, and then we're spending 4% more from year to year. Therefore, what's our inflation rate starting off? Well, spending 4% more and getting 4% more output, you should remember that that leaves 0%. So there's not going to be higher prices because all of our extra spending goes to extra output, right? And you want to remember, we're always using this equation. Spending growth, we're always using this equation. Spending growth, which I'll label delta MV, equals real growth, which I'm going to label delta Y, plus inflation, which I'm going to label pi. Okay, so my spending growth at 4% equals my real growth at 4% plus my inflation rate at, of course. Now, we're going to have a series. Let's draw that short run aggregate supply curve in there also. Let's see, yeah, it's in blue. Short run aggregate supply looks like this. And remember, the short run aggregate supply curve slopes up due to price and wage stickiness. So the level of spending, the aggregate demand curve, it matters now, because if it goes down, we're going to have output go down like this and prices go down like this. Instead of just, if spending went down, we could just have lower inflation and stay at the 4% growth rate. But that's not the reality, because if spending goes down, wages can't go down. And so workers find themselves too expensive, right? So then they become unemployed. Firms will do layoffs rather than pay cuts. So as spending goes down, let's do this in red. Okay, so spending goes down to this level and into this level. And finally, we end up down here. Okay, so our equilibrium goes from here. Let's label that A to B to C to D. And what did I say over here? I said inflation can only decline by 12 percentage points. So starting at 0 and declining by 12, that leaves inflation at what? Minus 12%. And spending growth has declined to negative 25% per year. So AD, let's label this AD 1, 2, 3, 4. AD 4, our spending growth rate is minus 25%. So spending growth of minus 25 now adds up to real growth, which we'll solve for, plus the inflation rate, which is minus 12. So minus 25 equals what plus minus 12, or what minus 12 equals minus 25. And of course, you can solve that easily. That's going to be minus 13. So my real growth rate here is going to be minus 13. And of course, this is actual history. This is the Great Depression, going from 1929 to 1933. Okay, negative aggregate demand shocks caused by a collapse in the money supply. Remember, what is spending made of? It's made of money. And if money goes down, spending goes down. And if spending goes down, the economy goes into depression because of the sticky wages effect of the short run aggregate supply curve. So basic monetary caused downward business cycle, the worst one we've ever seen in world history in the early 1930s. So the final, okay, so we've solved those equilibrium inflation and real growth rates, -12 and -13 respectively. Now we're going to say, would a monetary policy response be appropriate for this scenario? Well, it was money, it was a collapse in the money supply that caused it, right? That's what causes the negative aggregate demand shock. So would a monetary response be appropriate? Of course. And the monetary actions needed would be to shift the aggregate demand curve back to where it started. So if the Fed had done its job right, the Fed could have increased the money supply by utilizing its reserves to make loans to banks, lender of last resort function. That's what the Fed should have done and didn't. What eventually gets us out of the Great Depression in 1934 is the government itself, via the president, President Franklin Roosevelt, devaluing the dollar and instantly increasing the money supply. So if you instantly increase the money supply, you instantly increase spending, because that, money is made of M times V. So you increase M, that goes back up, and then you go back to an inflationary environment. You climb up the short run aggregate supply curve, and the economy starts growing again at something like 4-6% in 1934, because a monetary induced positive aggregate demand shock. Spending gets you into this recession, an increase in spending is the only thing that's going to get you out of it. Okay, let's move on to number 2. Okay, I've gone ahead and set this up here with my primitive drawing technology, and it says this: an economy has been operating in a full employment equilibrium with a real growth rate of 3%. I've got that right here. A positive supply shock, positive real shock hits this economy, causing real growth to increase by 3 percentage points. So we know we're going to go like this. And we're starting at 3, we're going to increase by 3, so we're going to wind up at a 6% real growth rate. Okay, so 6%. That's going to take us up here. Let's just go ahead and label this 2. This is going to be LRAS2. I'm just going to label this LR because it's very difficult to draw letters in this program. Okay, so long run aggregate supply 2, positive real shock like this. Okay, so it says AD growth remains constant at 5%. So I'm not going to shift aggregate demand here, total spending. I'm just going to shift aggregate supply, which is the capacity of the economy to produce based on its real factors: land, labor, capital, technology. Okay, so we have more technology maybe, or more natural resources. Like this could be a positive oil shock. Okay, so any combination of those things is what's happening. So now we're going to do this: the initial equilibrium, including initial inflation and real growth. Well, initial equilibrium, we've got 3% real growth, and inflation would have had to have been, inflation would have had to be at 5% total spending and 3% real growth. Inflation would have had to be what? 2. Okay, so there's the initial. Let's put a dot there and let's label that A, if I can. Okay, the positive supply shock, growth in inflation rates. Let's circle that. Let's make the initial ones here in yellow. Okay, and then let's do the final in, let's see, let's solve it and then we'll highlight them. So inflation is down to this level here. 5% growth, 6%, 5% spending growth, 6% real growth. That means what? -1. So we've gone into deflation. Oh no, deflation, right? In the last problem, deflation was bad. It was a sign of collapse in money and spending. But is that the case here? Well, no, we've got 6% real growth. And let's highlight the final equilibria here. Let's go with green. So I've got -1% inflation and 6% real growth. Positive supply shock brings inflation down and growth up. So I'm not worried about this deflation at all. This is good deflation. All right, so it says in part C, assume the central bank has an explicit inflation target of 2%. What monetary policy action would be necessary to maintain inflation at 2% after the supply shock? Well, to bring inflation up, what does the Fed have to do? In any case, it has to increase aggregate demand, right? And what that would do for us here, let me draw a short-run aggregate supply curve associated with the new long-run aggregate supply curve. Let's just label this SR2 if I can. So what that would do is take us up to a higher growth rate here, which could be unhealthy in the short run because it's an excessive growth rate, right? So we could get inflation back up to 2% here, but only if we got growth maybe above its already very high level. So that could be a cause for kind of an inflationary boom or an excessive inflation rate. It's debatable. So when I ask you, do you think this monetary policy action would be a good idea? I want you to tell me what you think. There's not necessarily a right or a wrong answer here. There definitely is a right answer in terms of if we have this much of a positive supply shock with shifting the long-run aggregate supply curve to LR2, we could definitely calculate that inflation would do this and real growth would do this. So there's an objectively right answer, but whether or not it's a good idea for the Fed to make this move, that's going to be somewhat subjective. Okay, so that's practice with the aggregate supply demand model. I'll also kind of remind you to review that homework 5, homework 4 and 5, aggregate supply demand practice problems, which we went over pretty extensively in class, so I'm not going to do those again here. But we will move on with the rest of these study guide problems. So let's go to number 3. Okay, number 3 says, due to innovations in banking technology, the Federal Reserve decides banks don't need as many reserves and so reduces legal reserve requirements. That means the reserve ratio the Fed imposes on banks, right? How much of deposits they need to hold as cash or reserves as liquidity, right, to be available for people who want cash from the bank. We're going to reduce that from 10 to 5%. Okay, so let's do a little bit of review with the money multiplier. Let's remember, let's actually just type in here, MM equals 1 over RR. Okay, so if the RR, so if, let's call this RR1, equals 10%, then MM1 equals 1 divided by 0.1, put it into decimal form, and of course that equals 10. Okay, now MM2 is going to be 1 divided by 5%, 0.05, put it all into decimal form, and that's 20, right? This question here is basically the same as how many nickels are in a dollar. If I divide 100 units into 5-unit increments, I get 20 of them, right? So the multiplier's gone from 10 to 20. And remember, the multiplier is because the money supply is like an inverted pyramid. For every dollar increase in reserves that happens down here, which I'm just going to label it B this time because I hate trying to draw letters with this tool. Okay, monetary base that the Fed creates. If that goes in, if new reserves become bank deposits, a bank can lend it out, it gets deposited in another bank, and then that bank can lend it out, and then that gets deposited into another bank, and then that bank lends it out. So that multiple deposit expansion process, you'll recall, is why M1, which includes deposits, is going to be substantially larger than MB. I'll go ahead and call this MB here, just to avoid confusion. Okay, so MB could be 100 billion, let's say. MB down here could be 100 billion. Okay, at my initial multiplier, M1's going to be 10 times that, 1,000 billion, which is a trillion, right? At my new multiplier of 20, M1's going to be 2,000 billion, or 2 trillion, right? So that's how this works. That's how the multiplier works, and we have to keep that in mind. We've calculated the value for the multiplier before and after this change. Now we want to talk about what banks do. Do banks engage in more or less lending after the change in RR? Well, what we've done to um, banks is basically freed up more of their deposits to be able to be lent out. So what this kind of change would do would change the shape. It's not changing the amount of reserves, but it is going to change the shape of the I got to go back to pencil here. It's going to change the shape of the money supply pyramid. So it's going to make it broader like this. So that means the same amount of base down here, which I'll draw this triangle a little bit smaller. So the red monetary base amount is the same as this was initially. I'll shade that in black here. Okay, so this was the initial monetary base, what I'm shading in black. And that's the same as what I've created here with red. Same amount, 100 billion. Okay, but M1 now, instead of being 1,000 billion, let me put that back in. M1 was over here. M1 over here was 1,000 billion or a trillion. Now it's 2,000 billion or 2 trillion. Okay, because we freed up reserves for banks to create more loans. In this extreme example, going from a reserve ratio of 10% to a reserve ratio of 20% would cause this change. Okay, so would that increase or decrease money growth? Well, of course, M1's going from 1,000 billion to 2,000 billion. That's going to increase money growth, isn't it? So that's one way the Fed could alter the money growth rate if it wanted to. Normally, it does that through open market operations, but this is another tool the Fed has at its disposal. Okay, let's go on to number 4. Okay, now number 4, it says using a supply and demand diagram for the loanable funds market or the credit market, which I've got set up here in the drawing tool. A, we're going to demonstrate the open market operation, sales or purchases, that the Fed is going to use to undertake to raise interest rates. So the price of credit is the interest rate. Supply and demand. Supply is basically the amount of reserves that banks have. That's the basis of all their lending, remember. And demand is based on businesses and consumers who want to go and borrow now. They want to spend now, but they don't have the money, so they go and borrow it from banks. Okay, so we know the Fed wants to raise rates. So I'm going to draw that in first. I'm going to draw I2, and I'm going to kind of put that line across. The price is going to be up here at this level. Okay, now what does the Fed do? Does it control supply, reserves, or demand? People's eagerness to borrow? Well, it clearly only controls supply. So we can go ahead and shift supply as the Fed to a level which puts our equilibrium price up here. So price has risen, the interest rate has risen from I1 to I2, and consequently the quantity of lending and borrowing has fallen down to Q2. Right? And make sure, just like supply and demand we've been doing all along, all semester here, we're going to draw the equilibrium points. We could label this if you want. We went from A to B, right? And I want to see the price go up on the axis here. So I want to go from I1 over here to I2 like this, and the quantity from Q1 to Q2 down here. Okay, so we go A to B, Q down, price up. So and this is S2, of course. Never forget to label those curves, people. Now the question is, how did the Fed do this? Did it do open market sales or purchases? The Fed, in order to make these changes, the Fed is going to transact with banks, big Wall Street banks mostly, that have a tremendous amount of reserves on their own. And so when the Fed changes their reserves, that will kind of ripple throughout the rest of the banking system and the rest of the economy. So does the Fed want to buy government bonds from banks or sell government bonds to banks? We have to think about which one of those actions would take reserves away from banks, would take money away from banks. And of course, if you said the Fed wants to sell government bonds, you're correct, because the banks will pay the Fed with the reserves, and that means reserves go down. That's what drives the supply curve to the left. So this is open market sales. The Fed sells off some government bonds to banks. Banks basically replace, or they exchange reserves for more government bonds, and they pay those reserves over to the Fed. And once they land back at the Fed, they're no longer the basis of banks lending. So that's why we can see that this makes sense as well. The quantity of lending and borrowing goes down and the interest rate goes up. Okay, so that summarizes what the rest of this problem gets at. What would be the effect on total bank reserves? They would go down or they would grow at a slower rate. Money supply growth would slow down and aggregate demand would also decrease. Okay, under what circumstances would the Fed desire to undertake this action? Well, remember the Fed has a dual mandate. The Fed's there to tackle inflation and unemployment. So whenever the Fed is decreasing aggregate demand, it's probably worried about inflation getting too high and the economy being overheated. In fact, that's kind of the mode the Fed is in right now. Inflation isn't really heating up, but the Fed wants to make sure it doesn't, perhaps. So if the Fed's worried about inflation rising, and we're at full employment and full growth rate, then the Fed might start ticking that interest rate up bit by bit. So we never get to a level where inflation is too high, and then the Fed has to take drastic steps like it did under Paul Volcker back in the 1980s, the early 80s. All right, so that's the kind of situation the Fed would be doing this kind of policy. Okay, now question 5 just talks about the opposite of this. So let me see if I can just unwind what we just did. Let's not do that open market sale maneuver. All right, so I'm back to my initial equilibrium here. Okay, and I'm in question 5, using supply and demand for loanable funds, demonstrate the open market operation the Fed would undertake to reduce interest rates. Okay, you can probably see where we're going to go here. The Fed wants to push interest rates down. So I'm going to draw I2 down here. And knowing the Fed controls the supply, the Fed can shift the supply curve out like this, increase supply of reserves. Let's label this S2. Don't forget to label. If you have everything perfect in your graph, but you didn't label S2, it's going to be -1. I'm going to nibble the points, so don't let me do that. Okay, and we're going from A right here, A to B. The Fed can push the interest rate down as much as it wants because it can add as many reserves as needed to get the interest rate where it wants it to go. And then, of course, the quantity of lending and borrowing is going to go up to Q2 like this. Okay, so that's the move we would see in the supply and demand diagram. How does the Fed do that? Open market sales or purchases. Remember, with open market sales, which we just did, the Fed sold bonds, banks paid with reserves, so reserves went away. Now, if the Fed does open market purchases, let's call that OMP, the Fed is going to buy government bonds from banks. And how does the Fed pay for the government bonds it buys? It gives the banks brand spanking new reserves. So this causes an increase in reserves, an increase in lending, because reserves are the raw material that banks lend, and a decrease in the price of lending or borrowing, right? So reserves go up, money growth goes up, aggregate demand goes up. Under what circumstances would the Fed undertake this action? Probably if the economy's sluggish, if growth is down, if inflation's very low, and or unemployment's very high. Fed wants to increase aggregate demand to push the economy up to a higher spending rate and hopefully a higher growth rate. Okay, so there's a monetary policy review. Let's move on now and do some fiscal. Okay, I'm just going to talk about these, and I'm going to type some stuff in right into this. It'll be a little more efficient. So this one says, President Trump pushes a massive supply-side fiscal stimulus of tax rate cuts through Congress. Okay, remember, there's 2 ways to do fiscal stimulus. Let me just type some notes in here. 2 ways to do fiscal stimulus. And let's note that that's aggregate demand. Government spending increases. And B, we can do, oh, and let's label that. Let's label that. That would be known as kind of demand side or Keynesian type policies. Or B, we could do tax rate cuts, which would be, that could be demand side in terms of it's aimed at increasing consumer spending. So from the consumer standpoint, But that's also supply side because it would increase aggregate supply if it got businesses to invest more. So kind of from the business perspective, that's more of a we would call that a supply side policy. Okay, so that's maybe double barreled stimulus, right? You get consumers spending more because they have more income after tax, and you get businesses investing more and creating more capital, which increases your growth rate. So that brings us to the second part of this question. Under what conditions might government revenue decrease? Well, that is the tax cut effect, which means government revenue goes down, is going to be larger than the economic growth effect. Because more economic growth could mean government revenues go up. So the raw reduction in tax rates has a bigger effect than the possibly higher growth rate that you get because of this. So government revenue, now it's possible that eventually government revenue could go up because economic growth goes up. And even though you have a lower tax rate, you have a larger tax base, so the government collects more revenue. We're not going to get into the details of that. We'll try to keep this kind of simple. So what might we expect to happen to government revenue as a percent of GDP? Government revenue will most likely go down. If the tax cuts lead to an increase in the government's deficit, why might the stimulus program not really stimulate the economy? What would Ricardo do? David Ricardo, not Ricky. Well, remember from the homework, Ricardian equivalence. So I'm going to say here, people in the Ricardian scheme, people interpret larger deficits and more government debt as meaning higher future taxes, and therefore save more today in anticipation of suffering higher taxes in the future. Remember my metaphor in class about the wealth castle or the wealth fortress. If I think I'm building up a wealth castle because I want to have money, I want to have wealth, I want to have a retirement, or I want to own a yacht, or I just want to live it up, whatever. So whatever reasons people want wealth, um, they're saving and investing to build that wealth. If the government is going to, so to speak, siege my wealth castle in the future, I need to build thicker walls now, which means higher current rate of savings. And if savings goes up, consumption goes down, ergo no change in aggregate demand in the short run. Okay, so that's just kind of another application of that Ricardian equivalence concept, which is the kind of the ultimate form of crowding out. Let's move on here. Number 7. List 3 methods government can use to pay for its spending. 1. Direct taxation. And remember, my motto here, all taxes are income taxes. I don't care how they're labeled. Number 2, deficits, which, of course, government borrowing and accumulation of larger government debt, which is in the form of government bonds, of course. And one of my mottos when I talk about fiscal policy, you'll recall, is deficits. Fiscal policy implies deficits. Fiscal policies, expansionary fiscal policies, supposed to increase the deficit. But if you get in permanent deficit mode, which the U.S. is kind of in, I would argue, you're going to build up a lot of government debt. More government debt, so let me put it this way, deficits imply larger government debt. Growing government debt implies what? Higher future taxes. Or future government spending cuts, which I think are unlikely. But either one of these would cause a negative aggregate demand effect. Okay, and then finally, if the government finds itself over indebted, too much debt, and unable to borrow more from the world's credit markets, right? Savers, banks, businesses, whoever has money that they want to invest, they usually will buy government bonds up to the point where they say, hey, this government has too much debt. We're not going to lend more money to that person, right? It's kind of like the bank won't lend you money if you go bankrupt. So if the government finds itself unable to borrow more, we will go to printing money, also known as inflationary finance, also known, depending on how it's done, it could take the form of debt. Let me go down here. Could take the form of what we call debt monetization. That's when the central bank, for us, that's the Federal Reserve, prints money to acquire or pay off all those government bonds. Many people were worried when the Fed started buying government bonds in large amounts in 2008 because that kind of smelled like debt monetization. The Fed gets its money from nowhere, right? It can create reserves. It uses those reserves to buy up several $1 trillion worth of government bonds. So the Fed kind of becomes the main vehicle there to finance a government debt. That's why this makes people nervous. You're going to have your central bank become the main financer of government. That eventually will become inflationary, kind of depending on the size of the economy and whether the government's collecting much taxes. In our situation, the government's still collecting a lot of taxes. Most of its financing is through taxes. But if you get to a critical mass where the central bank's doing enough of that, it's going to become inflationary. Okay, so this is called inflationary finance because all this creation of new money to finance a government debt will create inflation. We want to think about that in this way. If M goes up, will too much, that will ultimately cause higher inflation. What do I want to say about inflation? Inflation is a tax. Why? Because of early late recipient effects. Government is always going to be the first or a very early recipient, so they can spend the money before prices go up, right? And you want to think of it, inflation kind of takes place in rounds. Round one, the government creates some money, it spends it, that causes prices to go up. Okay, the government prints some more money. Round two, it spends it, that causes prices to go up even more. So early recipients, while inflation might be happening, they spend the money before the next round of price increases. So that's why you always benefit as an early recipient, even if inflation is rampant, because you get your hands on all that extra money first. Right, and then we also, of course, have debtor-creditor effects. And if you're not familiar with the terminology here, well, you should be, but debtors are borrowers, right? Creditors are lenders. Which is the government? Is it a debtor or creditor? The government is this. I mean, big time, right? The U.S. government is the largest debtor entity ever. So debtors see the real burden of the debt go down, and they therefore benefit from inflation because they are repaid in cheaper dollars. Or let me put it this way: they pay off debts or refinance them in cheaper money. Creditors are repaid in those cheaper dollars, so creditors can be really burned by this. Creditors could get their nominal money back, but that money's become worthless, so there was no return on the investment. Okay, so that explains. Okay, those are the two distributional effects: early late recipient and debtor creditor. And it makes sense that an indebted government, notice my emphasis here, would ultimately rely on this because government's the biggest debtor ever. Okay, so that's maybe kind of the easy way out for an over-indebted government. Going down here to step 3, using inflationary finance rather than increasing taxes, and it find itself needing to do this when and if it can no longer engage in deficit, freely finance its debts through issuing bonds. Okay, explain the open market operation that the Fed undertakes to engage in expansionary monetary policy. Now let's talk about expansionary, contractionary for a minute here. What the heck do we mean by expansionary? Expansionary monetary policy, ultimately what we're trying to do with that is push aggregate demand up. They're trying to push aggregate demand up, get people spending more, and climb the short-run aggregate supply curve to push the growth rate up. Maybe even push inflation up. In the Great Depression, we had deflation. The Fed wants a higher inflation rate. If your inflation rate's -12, you definitely want a higher inflation rate. That's also associated with unemployment of 25%. So you want more growth, more spending. As spending goes up, people are buying more, businesses are producing more, and that, of course, brings your unemployment rate down. Okay, so that's the goal. Okay, let's type that down. That's the goal. The means of achieving that goal is to increase money growth, higher rate of money growth. Now, how is the Fed going to create more money in the system? Well, it's going to issue reserves. And remember back to that question about supply and demand for credit, right? The Fed issues reserves when it buys government bonds. So the Fed is going to buy government bond. Fed wants to issue new reserves, new/more reserves to the banking system. The tool that we'll use to do that is open market purchases, right? Remember, the Fed buys government bonds from banks and pays for them with new reserves that it creates in the process with its monetary creation powers. And if you go back to the supply and demand portion of the video, we're still working through that process where the supply increases, interest rates go down, banks lend more, people borrow more, and that's what causes money growth to rise. Okay, so interest rates go down, M1 goes up, M1 will go up more than the monetary base because of the multiplier effect. And how does that increase total spending? Well, I just mentioned this. People borrow more from banks, right? And that's a lot of that's going to be businesses borrowing more to finance more operations, to expand, buy new capital, hire more workers. Why would higher total spending lead to a higher growth rate? Well, that's where we're climbing the aggregate supply curve in the short run. Because when you increase total spending, certain prices are going to rise immediately, like consumer prices, and other prices are going to lag behind that, like wages, right? So in the short run, an increase in spending and aggregate demand will cause an expansion of economic activity. Now, in the long run, wages will rise too, and costs will catch up to product prices, and that stimulative effect can go away. And that gets us into this issue here of why can't monetary policy permanently reduce interest rates? Well, let's review this idea of the Fisher equation and the Fisher effect. Fisher equation says that nominal interest rate is equal to the real interest rate plus the inflation rate. Okay, so if the Fed pushes nominal interest rates down by issuing more money, right, higher rate of money growth, well, more money will eventually cause inflation, right? So if I increase the inflation rate, I'm going to tack that on to actual real interest rate and increase the nominal interest rate. Okay. And let's go back to the drawer. Let's go back here to maybe think through that. So okay, let's write down the Fisher equation, and I'm going to write this down in symbols. So nominal interest rate I'm going to call I equals the real interest rate, I'm going to call that R, plus the inflation rate, which I'm going to call pi. Okay, that's exactly what I mean here. Nominal interest rate equals the real rate plus the inflation rate. So let's start off with a let's say we have a nominal interest rate of, let's say we have an inflation rate of 2%. Let's work backwards here. 2% inflation plus, let's say, 2% real interest rate. So the amount banks charge is going to be what? 4%. Now, Fed wants to reduce that. Okay, so here's what the Fed does with its expansionary monetary policy, open market purchases. Here's what the Fed's going to do. Let's just pick a round number here. They're going to do 3%. Okay, now this is what they initially do. So let's say they push the real rate down temporarily. They make it apparently lower. Inflation stays the same initially. But remember, when the Fed starts creating money, inflation happens in rounds. That new money flows through the economy and starts putting upward pressure on prices. So in order to do this, the Fed created more money, and what more money is going to do is push this inflation rate up. Let's just say it goes to 5%. And even if the real interest rate stays at this lower level, which it's probably not, let's just hold it there for a second. Well, you'll notice that nominal interest rates are still going to be higher. Okay, the nominal interest rate is now up to 6 after the inflation takes hold. And real interest rates have a tendency to reassert themselves. So what we might ultimately wind up here with is something like this. Let's say our real interest rate goes back to 2%. And the inflation is up at this higher level of 5% still, because the Fed has undertaken expansionary policy, more money in the system. And now nominal interest rates might rise even further. And if this sounds familiar, when we study monetary history, what does this look like? This looks like what's happening in the 1970s. Okay, this is that 1970s show, Monetary Policy Edition. And that's why the inflation rate builds up and the interest rate goes up. And then to kill off the inflation, Tall Paul Volcker has to push the real interest rate up even higher by raising nominal interest rates even higher. And that causes a painful recession. And then that kind of brings us to the concept of, maybe should the Fed even do this, right? The Fed's got to be really careful about it, even trying this, because it just can easily create an inflationary spiral and overstimulate the economy. And then the Fed kind of becomes an agent of business cycles rather than a cure for business cycles. Okay, so that's that. Enough on monetary policy. Let's do one more thing here, which is kind of a throwback to Unit 3 and Midterm 2, calculating real prices. This is something that's really important for you because I don't want you to be fooled by inflation. So I want to work through calculating real prices one more time. Okay, so let's work through another kind of quasi-real life example here where I'm talking about how my dad used to complain about the cost of ice cream bars. Right, so I used to ask my dad here for an ice cream bar. Give me $1. The ice cream trucks rolling through my neighborhood. I could tell because you hear the songs they play from their loudspeaker. So all the neighborhood kids are running out there, cash in hand, to buy themselves an ice cream. My dad likes to kind of scoff and say, when I was a kid, ice cream was so much cheaper. Let's say it was $0.25. I don't remember exactly. All right, but I'll, as an economist say, yeah, Dad, the price level, look at the CPI here, the Consumer Price Index, was also a lot lower. So which has gone up more, the price of ice cream or the price of everything? That's why we're going to start off with this percent change. Remember the percent change formula. X2 minus X1 divided by X1. What is that going to work out to here? Well, we just do this on a calculator. $1 minus 25 cents. So the difference is 75 cents divided by the X1, or the starting point, which is the 25 cents, divided by the 25 cents. So that's 3. Probably do this in your head, but go ahead and multiply it by 100. So that's going to be a 300% increase in price. All right, now meanwhile, the CPI has done this. The CPI, the X2 there is 118. It started at 29, so it increased by 89 divided by its starting point of 29. 3.068. Let's multiply that by 100. 306.9. Let's just round that up to 307%. All right, so the price level itself went up by slightly more than the price of the ice cream. So I know that my real price changes for ice cream are going to be negative. Now, regardless of whether I put it in, I'm going to replace this here, 1958 terms. Every time I see the word old, let's be explicit, 1958 terms or new terms, which for this example was 1988. Okay, so to find the real price at 1958 terms, that's what we're doing in this column here. Well, first of all, the 1958 price is already in 1958 terms, isn't it? So that's just going to carry right over here. I'm just going to dump that right in there. And we could technically say the factor that we're multiplying by is 1 if we wanted to. If it helps, just leave this blank. We don't even need to bother with that. This thing just drops right over here. Okay, now the CPI factor, and look, okay, for my CPI factor, I'm saying what value takes me from the new CPI in 2018? No, it's not 2018. What value takes me from the new CPI, in this case in 1988, back to the old CPI for 1958? Okay, the CPI here in 88 was 118. And I'm saying what would take me back from this value back to the CPI then, which was 29? Okay, what's the factor? What multiplier takes me in that direction? So the math looks like this: 118 times x equals 29. Simple algebra here. Solve for x by dividing out this coefficient divided by 118. That cancels. Divided by 118. So x equals 29 over 118, and that's what I'm going to do here. Equals 29 over 118. And that equals what? Use your calculator. 0.245. Let's call that 0.246. Okay, now I'm going to multiply that factor times the nominal price of 1988, and that's what's going to bring it down to 1958 levels. 24, let's call it 0.246. Of course, it's times 1, right? So it's going to be now $0.246. Okay, so it's hard to, if you round this, you won't see the price change. That's why I'm not rounding it. I'm going out to the thousandth place there, but then we can now compare this price. We can calculate this percent change. Okay, the x2 is 0.25. The x1, all right, let's start over. The x2 is 0.246 minus the x1 of 0.25. So the difference is that divided by the x1 of 0.25 times 100. So I got a 1.6. It's not much, but it's negative. We got a 1.6 negative percent change. Okay, now bringing things up to the newer price level of 1988. Once again, this nominal price is already in $1988, so it can just copy directly over. I'm going to dump that in here. Okay, and the factor is 1 if you like. You can leave it blank, I don't care. What we need to do now is calculate that price factor going the other direction. So now I'm saying what brings us from 1958 price level to the 1988 one. That's moving the opposite direction. We started at 29 and we're coming up to 118. So the math's going to look like this: 29x, 29 times what? X equals 118. Solve for x equals 118 over 29. All right, so that's right here, equals 118 over 29. Do that on your calculator. It's going to be about 4.0, let's call it 4.07. Okay, and now multiply that by your old price. You can do that right here. There's that value times the old price of 0.25. 1.017. 1.017. Let's go with that. Okay, and that's my x1. x1 minus, I got to start with x2 rather. Let's clear this. x2 is $1 minus the x1, 1.017. There's my difference divided by my base, which is 1.017. Gives me a percent change difference of, let's multiply by 100. 1.67. Okay. You call it 1.7%. And the only reason there's a difference between these two values minus 1.6%, minus 1.7 is because of the way I rounded. Usually those will come out exactly the same. Here they came out pretty darn close. So complete the table to find out the real price of Old Man Watt's childhood ice cream. It was slightly higher, Dad, because inflation was more than all of the difference in the change in the nominal price, right? So if my dad wanted to complain that things were worse when I was a kid because ice cream was more expensive, I could bust out my CPI values and do a little bit of macro math and say, no, Dad, things are as good, if not better, because real prices are actually lower. And if you look for most consumer goods, especially for things like food and clothing, real prices are lower for comparable items. The only reason prices might be higher today for a lot of things is because it's better now, right? Clothing is better, it lasts longer, it's made of better materials. A lot of food products are also better. So don't be fooled by the changes in nominal prices over time. The economy's grown a lot, and a lot of inflation has happened. So we need a tool, remember, to see through that inflation and the consumer price index, and doing real price adjustments like we're doing here is a very valuable and useful tool to do that. Okay, that is it for our review. So I hope you can watch this and work through these problems and study and be prepared well for the exams on Monday and Tuesday. I will see you there.